We are using the remainder theorem, level 1. What the remainder theorem is saying is that if we have a polynomial divided by a polynomial, that we would look at the zero here, and just plug that in to our function. So whatever makes the 0 here, we use that to plug into our function. So when is x minus 4 equal to 0? When x equals 4. So then we take that 4 and we plug that into the function. So we would find f of 4. What that does is it tells us what is left over if I divided the x minus 4 into the 3x cubed plus 5x squared plus 5. So what would be the remainder if I divided this into it? Okay. So all you do is you plug the 4 into the function because that's the 0 here. It's just a theorem. So that would be 3 times 4 cubed plus 5 times 4 squared plus 5. Exponents come first. 4 times 4 times 4 is 64. 4 times 4 is 16. And still have plus 5. So 3 times 64. Use a calculator. 3 times 64 is 192. Five times 16. 80. Plus 5. Okay. What's 80 plus 192? That'd be 272 plus 5, 277. 272 plus 5, 277 is what I get as my answer. So that would be the remainder. So it's for this theorem, all it's telling you is the remainder. It's not telling you what you have left over. So the key is what you would really use this for is if in math, if you're deciding does it go into this evenly, all you have to do is the remainder theorem to see if it goes into it evenly. If it goes into it evenly, then your answer is pretty clear. It needs to be simplified. If it doesn't go into it evenly, then usually you would stop right there. All right, but we're just asking for the remainder, 277. Okay. And they did the same thing. They're not explaining it, and then they're also using like a synthetic division just to show you how they would do it the long way. Next problem. All right. So what's the 0 here first? Well, first let's read the problem. If this is our function, then what is the remainder when f of x is divided by x plus 2? So we need to find the 0 of x plus 2. This is not too bad. We can start to see and streamline it a little bit. The shortcut is the opposite of that number. So that's a minus 2 is the 0 here. Then that gets plugged into our function. So f of negative 2 is going to give us the remainder. So I just plug a negative 2 in wherever I see an x. Have to have parentheses here. And then exponents come first. It's an even exponent, so I know the output's going to be even. 2, 4, 8, 16, 32, 64. Negative 2 times negative 2 is positive 4. 2 times 64 is 128 plus 6, which is 134. All right. So what this is saying is that if you divided x plus 2 into 2x to the sixth plus x squared plus 2, the remainder will be 134. We'll still have that left over. Okay, so it does not go into it evenly. Same strategy. Yep. And there's that synthetic division again. So it's good to kind of look over it. That's coming. So there's our 0 they're using. And then we just look at the coefficients of each power. And if the powers are missing, we have to have 0 placeholders in there. Same type of problem, it looks like.